Hello, I'm Catherine Starr, and welcome to my instructional design case analysis. The case I analyzed is a project by the Lang Society integrating the video game Minecraft into a course on microbiology. The development team ranged from biology teachers to technology specialists. The 2-week course was part of a summer program for 14 to 17-year-olds at the American Museum of Natural History in New York City, to be integrated into a special exhibit, The Secret World Inside You, about the human microbiome. Research shows that technology, multimedia, and games facilitate learning by enhancing motivation and encouraging collaboration. The thinking was that the familiar and approachable platform of Minecraft could be used as an engaging tool for contextualizing and grasping the complexities of microbiology. Minecraft could also be used as a virtual lab where simulated activities could provide hands-on experiences to students where they could manipulate the environment and observe reactions. The 5-member design team had only 1 month to develop the project. They don't label their design process, but the detailed descriptions of their collaborative brainstorming and daily iterations of design development and test cycles and frequent communication between team members would indicate a SAM or Agile process. They provide fascinating detail about ideas they considered and decide against, as well as what they chose to go with. Early on, they abandoned the idea of fully utilizing the open-ended sandbox nature of Minecraft because they wanted to ensure that gameplay was being used to leverage student comprehension of microbiology concepts. In an effort to strike a balance between freedom and structure, they opted for objective-driven minigames that combine free play within a structured environment designed to contextualize microbiology learning objectives, which were created to coincide with the museum exhibit. They decided to create a giant map shaped like a human body that would contain the 5 learning activities in the appropriate corresponding areas, like the cut on the arm where the microbes are fighting off an invading infection. They made a map of a female figure for the student projects, but little of this is mentioned in the design phase, which turned out to be a design shortcoming. Throughout the design process, there were weekly meetings where ideas were storyboarded and testing of the activities was done daily. One of the problems they encounter is that, as they put it, Minecraft is not designed for class use. Honestly, I was pretty surprised by some of the difficulties they encountered at this stage because it struck me that the Minecraft subject matter experts seemed unfamiliar with some of the features of server gameplay, like dispensers rather than chests to provide players with necessary items. They installed Minecraft EDU mod to address these issues, but determined after the fact that they did not actually need it. To leverage the game experience as reinforcing the lesson concepts, it was necessary to replace Minecraft terminology with microbiology vocabulary. But renaming the objects in the game was not enough. They had to actively work to integrate the new vocabulary into the students' speech. They did not have access to a computer lab, so the program consultant's personal laptop functioned as the server. Apparently, Minecraft EDU only runs on a shared Wi-Fi connection, and the server could not host all 14 players. So the students were split into groups that played on a rotational basis. This slowed the process and required constant tech support. No remote server also meant that the students could only work on their projects during class. The designers underestimated the amount of time students would need for their final project due to their level of engagement and complexity of design. This cut into time planned for other learning activities, but the student activities are impressive. They are available as a downloadable map on the AMNH website. Analysis was conducted as a continual process of implementation. Students provided feedback through daily debriefings and also kept journals, which the project team regretted not collecting as an evaluation tool for themselves. They wish they had had access to a computer lab and recommend that simpler games on smaller individual maps be tried to avoid overdependence on a staff of technical support. According to the design team, the biggest design issues were Minecraft's complex building mechanics and the fragility of the game world and time requirements for the final projects. And 2 unexpected revelations were the value of reflection exercises to aid in the content knowledge transfer and the merits of design-based student projects. I'm really impressed and inspired by this project, and I think they demonstrated that Minecraft can be used as a powerful and valuable learning tool. I think they bit off a bit more than they could chew, but it serves as an excellent alpha prototype of what could be done. I see huge potential in taking the main idea of their project and scaling it up instead of down. I imagine that a dedicated server hosting high-quality, professionally created educational minigames is potentially marketable. Schools, groups, or individuals could access servers through a subscription service instead of many institutions struggling to create their own versions, which is inevitably inequitable as some institutions are just not going to have the resources to develop these types of dynamic learning environments. I would separate the student-created activities and work on fine-tuning ways students could create similar projects that are smaller and independent, but also perhaps remote server access to allow for portability. I think this is a very exciting and promising project, and I hope to see more endeavors like it or to participate in one. Thank you for watching.